Periodic classification of elements. In your classroom you could have definitely seen a periodic table. Didn't you? Well, did you ever thought how is the making of it take place? This was not so easy to make it. It was started to classify elements from 19th century onwards. In 1817 a German scientist named Dobereiner classified elements into triads. Dobereiner showed that when the three elements in a triad were written in the order of increasing atomic masses, the atomic mass of the middle element was roughly the average of the atomic masses of the other two elements. For example, one of the triads was lithium, sodium, and potassium with masses of 6.9, 23, 39 respectively. Here, we can notice that the average mass of lithium and potassium is 22.95, which is roughly equal to mass of sodium. Well, this was not only the triads but we also have two more trades. Calcium, strontium, barium are the second triad and the third was chlorine, bromine and iodine. Dobereiner could identify only three triads from the elements known at that time. Hence, this system of classification into triads was not found to be useful. The attempts of Dobereiner encouraged other chemists to correlate the properties of elements with their atomic masses. In 1866, John Newlands, an English scientist, arranged the then known elements in the order of increasing atomic masses. He found that every eighth element had properties similar to that of the first. He compared this to the octaves found in music. Therefore, he called it the law of octaves. It is known as Newland's law of octaves. It was found that the law of octaves was applicable only up to calcium, as after calcium every eighth element did not possess properties similar to that of the first. It was assumed by Newlands that only 56 elements existed in nature and no more elements would be discovered in the future. But, later on, several new elements were discovered, whose properties did not fit into the law of octaves. In order to fit elements into his table, Newlands adjusted two elements in the same slot, but also put some unlike elements under the same note. The main credit for classifying elements goes to Dmitry Ivanovich Mendeleev, a Russian chemist. He was the most important contributor to the early development of a periodic table of elements wherein the elements were arranged on the basis of their fundamental property, the atomic mass, and also on the similarity of chemical properties. The formulae of the hydrides and oxides formed by an element were treated as one of the basic properties of an element for Mendeleev's classification. He then took 63 cards and on each card he wrote down the properties of one element. He sorted out the elements with similar properties and pinned the cards together on a wall. He observed that most of the elements got a place in a periodic table and were arranged in the order of their increasing atomic masses. It was also observed that there occurs a periodic recurrence of elements with similar physical and chemical properties. On this basis, Mendeleev formulated a periodic law, which states that the properties of elements are the periodic function of their atomic masses. While developing the periodic table, there were a few instances where Mendeleev had to place an element with a slightly greater atomic mass before an element with a slightly lower atomic mass. The sequence was inverted so that elements with similar properties could be grouped together. For example, cobalt appeared before nickel. Further, Mendeleev left some gaps in his periodic table. Instead of looking upon these gaps as defects, Mendeleev boldly predicted the existence of some elements that had not been discovered at that time. Mendeleev named them by prefixing a Sanskrit numeral, Aka, to the name of preceding element in the same group. Electronic configuration of hydrogen resembles that of alkali metals. Like alkali metals, hydrogen combines with halogens, oxygen and sulfur to form compounds having similar formulae. Certainly, no fixed position can be given to hydrogen in the periodic table. This was the first limitation of Mendeleev's periodic table. He could not assign a correct position to hydrogen in his table. Isotopes of all elements posed a challenge to Mendeleev's periodic law. Another problem was that the atomic masses do not increase in a regular manner in going from one element to the next. So it was not possible to predict how many elements could be discovered between two elements, especially when we consider the heavier elements. The Modern Periodic Table by Henry Moseley. In 1913, Henry Moseley showed that the atomic number of an element is a more fundamental property than its atomic mass. Accordingly, Mendeleev's periodic law was modified and atomic number was adopted as the basis of modern periodic table. The atomic number gives us the number of protons in the nucleus of an atom, and this number increases by 1 in going from one element to the next. Elements, when arranged in order of increasing atomic number, lead us to the classification known as the modern periodic table. Prediction of properties of elements could be made with more precision when elements were arranged on the basis of increasing atomic number. The modern periodic table has 18 vertical columns known as groups and 7 horizontal rows known as periods. Let us see what decides the placing of an element in a certain group and period. You will find that all these elements contain the same number of valence electrons. Similarly, you will find that the elements present in any one group have the same number of valence electrons. For example, elements fluorine and chlorine belong to group 17. How many electrons do fluorine and chlorine have in their outermost shells? Hence, we can say that groups in the periodic table signify an identical outer shell electronic configuration. On the other hand, the number of shells increases as we go down the group. You will find that these elements of second period do not have the same number of valence electrons, but they contain the same number of shells. You also observe that the number of valence shell electrons increases by 1 unit, as the atomic number increases by 1 unit on moving from left to right in a period. Trends in the modern periodic table. The valency of an element is determined by the number of valence electrons present in the outermost shell of its atom. The term atomic size refers to the radius of an atom. The atomic size may be visualized as the distance between the center of the nucleus and the outermost shell of an isolated atom. The atomic radius of hydrogen atom is 37 picometer. By this we have completed our session. Let us revise what we have learned. Elements are classified on the basis of similarities in their properties. Dobereiner grouped the elements into triads and Newlands gave the law of octaves. Mendeleev arranged the elements in increasing order of their atomic masses and according to their chemical properties. Mendeleev even predicted the existence of some yet to be discovered elements on the basis of gaps in his periodic table. Anomalies in arrangement of elements based on increasing atomic mass could be removed when the elements were arranged in order of increasing atomic number, a fundamental property of the element discovered by Moseley. Elements in the modern periodic table are arranged in 18 vertical columns called groups and 7 horizontal rows called periods. Elements thus arranged show periodicity of properties including atomic size, valency or combining capacity and metallic and non-metallic character.